And welcome to the Daily Space Weather Show. We got a lot of stuff to cover and not a lot of time to do it, so we'll be doing this as slowly as possible, which happens to be blazing fast. We've got some violent activity both in that northwestern quadrant as well as the southeastern quadrant, which would be the upper right and lower left, respectively. We've got a very high likelihood of X-class solar flares, especially in that southeastern limb, your screen lower left. Also, multiple CMEs headed in Earth's direction, as we stated on the channel, and we're in agreement with NOAA once again. So some geomagnetic unrest or geomagnetic storm activity is on the way. It'll be some more banner moments for space weather. And by the way, thanks for tuning into the Smash News Network, least busted name in news. So this is our T-mass, the most active sunspot, and the most likely place to see a large solar flare. We just saw a nearly X-class event. It was like an M6.5, 7, something like that. We'll get to it. And we'll also get to coronal mass ejections to see what's been going on with those. But first, a brief look at what's going on Earth. So first and before that, there's our colorized magnetogram in SDO 171 angstroms wavelength. For today, March 18th, 2024. By the way, the lines are about to get straight. The Earth lines, that is. The shadows, yes, the equinox. The point where the sun crosses the Earth's equator. And, barely a day out, folks. You've almost survived another winter so far. Also, we have a crazy, absolutely bonkers, berserk, insane. Look at that. If that's not surreal, I don't know what is. That's going on right now in Iceland. Dag seems like a pretty good time for a trip to Iceland. I mean, it's the kind of thing that you go there and you go, I'm like, whoa, am I melting? Oh my God. I'm just kidding, folks. I have to mess with the color key here. And I know it may look like a live stream, but it's actually not a live stream, folks. These are recorded videos. We used to stream them, but because of certain features and lack thereof, now they're recorded videos. So yeah, that's what's going on at Iceland. Pretty sweet, right? So here's the new updated map, and what that says up in the upper left, I have no idea. So there it is. Those are fresh lava flows where it shows that lava color, I'm sure. And yeah, I'm not going to try to translate that. Ultinur telkanader efter tvelmur. No thanks. Anyway, volcanodiscovery.com's got the full write-up about what's going on Reykjanes right now. And yeah, it's pretty bonkers. Seems like a good time to go visit Iceland, especially with the likelihood of coronal mass ejections striking. So if you're going to jet set, well, might be a good time to book a trip. Sakurajima, Ibu, Merapi also erupting. Great image of Ravenador there as well. Also Dacono, Popocatépetl, Santiaguido, the usual suspects. Fuego, Nevado de Ruiz, Ravenador, Sabancaya. Next, our 90-day bar graph showing earthquakes. And look at that earthquake drought. You see that? See that? That's an earthquake drought of 7 and greater magnitude quakes, folks. So, yeah, if you're in an earthquake-prone zone, you might want to be aware of that. Earthquake droughts and enlarged earthquakes. So let's see what's been shaken. These are the 5 and greater magnitude quakes, like this 5.1 at Papua New Guinea, nearly 100 kilometers underground, though. So when a 5.1 happens at 100 kilometers, it's more like a 5.5 or something. So here's a 5.3 at in the Volcano Islands, south of Japan as well, and that's it. It's been very quiet. Is it the calm before the earthquake storm? Let us know what you think in the comments. And no, that's not a forecast. So nor is it supposed to be a forecast. So some more space weather stats here. The 10.7 centimeter radial flux has now jumped up to 177 solar flux units. So a rapid increase here in both sunspot number and the radial flux. And if you're a new viewer, The radio flux is a radio emission that comes out of the upper chromosphere and lower corona. Its flux density, which is measured in Jansky, 10,000 Jansky is solar flux units. That's what 177 is. 177 solar flux units, so it's ultimately 177 times 10,000 to get the number of Janskys that 177 solar flux units is. Janskys is a way to measure radiation traveling through the near vacuum of space. So it's ultimately radio flux density that is shown in the 10.7 centimeter radio flux. There it is in the convenient 1 year line there. The 10.7 is the black line. The sunspot number is the red. Continuing right along here, you can see forecast there, almost identical to what we said yesterday. NOAA thinks the CME will arrive sometime around midday on Wednesday. Yeah, Wednesday. And tell us if you know how to spell Wednesday in the comments. So anyway, we hope you're enjoying your Monday. Hopefully it hasn't been too torturous for you, returning to whatever it is you usually do on a Monday. Here are the past 4 hours of Earth's magnetic moment from space, and we have had some CME impacts showing up. Was it as forecast? Well, watch our previous videos for that. We're not going to rehash stuff we already said. That's the past 4 hours of Earth's magnetic moment from space. Here it is from the ground. We show it daily on the channel. Now, this is a good way to see the aurora. If you see that lighting up in your location, it's likely that there are telluric currents there, that there are the possibility of aurora overhead. So there you can see a little bit of an uptick, but it's looking pretty mild, the CME impacts we've seen so far. The next will be a little better. So the KP index now up to, what is that, 2.33. 2.33 is the KP index, an average of global geomagnetism. Next, looking at solar wind here, and we are seeing some strength here in the signal from the ACE. A little bit of an uptick there in both the magnetic field, which is that top line. The white line is the magnetic field density. And the red line is the magnetic field vertical orientation. So that's what you want to see for the aurora. An 11 nanotesla field with a negative 11 BZ, which is the red line. That's what you want. So that's a good thing. However, it is also pretty slow at only 355 kilometers a second. We are seeing hotter plasma as well, represented by that green line. Let's look at the Discover next, which shows a great view of this quite solid-looking CME impact. And it did ramp down rapidly. So that looks like a CME impact. And we have some more activity here, a second event showing up. Current conditions are BT of 10 nanotesla, BZ of negative 8, solar wind density of 8.3, and solar wind velocity of 351 kilometers per second. GOES magnetometers here showing a divergence around noon local time for the GOES 18. So a bit of a variation happening there. The N's and M's, these are showing you where the satellite is in location to the sun, in reference to the sun, obviously. That's noon local time for the GOES 16. That's noon local time for the GOES 18. And the M's stand for midnight local time for the satellites. So a bit of a field variation happening there in that short distance between the GOES 16 and GOES 18. Next are magnetic sectors for the heliosphere, and Earth is in a solidly south pole magnetic sector now. No changes coming anytime soon for that. Expect to be in the south pole sector for a few days. There it is shown in red. Here's our line of sight field plot, and the solar B field depicted here in blue, photosphere magnetism in grayscale, and then the polar fields, or what will become the polar fields, in red and green, respectively, south and north. Next is our line of sight coronal hole plot, and you're going to expect to see a lot of south pole oriented coronal holes, and that's exactly what you see. You can expect to see an ongoing uptick in coronal holes lasting the next 15 months, because we've had a real shortage of coronal holes, folks. And guess what doesn't happen with a solar cycle? Everything has a tendency to even out, folks. So the likelihood that you're going to see anything really super drastic happen with the cycle is really low. And, this is what people are this consistency is what people are using to forecast things that are completely silly and since debunked. Since the year about 2019, certain papers that were written in the year 2015 have been laughed at. And so, anyway, let's show coronal holes here from SDO. That's actually a 48-hour video. We decided to use some extra hours here to show the transmission of that coronal hole there in the southeastern limb, just ahead of that very active sunspot. So quite a lot of stuff going on there, you know, and keep in mind, folks, that coronal holes are kind of like, they're kind of like low pressure zones, okay? So you could think of this like a low pressure zone. Why is that? Well, because on a star, low pressure zones are so extreme that they blast material out into the greater solar system. That is what's going on around the edges of coronal holes. They're blasting material out in a feature known as the solar high-speed wind. So those coronal holes are the source of that. And, you know, there's massive amount of outgassing happening right in this area. But unlike a planet, the weather on a star is so extreme that it blasts protons out all the way into space. So these are things that the Earth does not do, okay? So I know there are some channels out there that are trying to get people confused about the difference between Earth weather and space weather, suggesting, oh, it's just the same thing, but the Earth isn't a star, you see. So saying, oh, this feature on the sun is just like, you know, oh, sunspots are just like hurricanes, is an idiotic thing to say. It's fully idiotic thing to say. And it just demonstrates that you don't understand sunspots or hurricanes if you think sunspots and hurricanes are really very similar. Because they're not. Because a coronal hole is nothing like a sunspot, but it is a little bit like a low pressure zone because material is coming out of the star and defying gravity. Whereas at a sunspot, that's not really what's happening until a CME happens. And so, I don't know. It's whatever. But, you know, people love to tie things together that aren't related in this strange non sequitur sort of a fashion, where they just see a thing and they're like, oh, it's like that. And it's like, but it isn't like that. But, okay. Anyway, check out the sunspot number. It's way up above the current average here, pulling the average higher and higher, which is what you can expect to see for the next at least 7 months. So now you might see it as long as like 14 months because some people who've been successful at forecasting solar activity, Bob Lehman, are suggesting, Scott McIntosh, that there may be a second peak to the solar cycle, or just a kind of a slant to it, where you never know, you may actually see it a little bit higher after the expected solar sunspot maximum. Because keep in mind, folks, you can't declare sunspot maximum until after it's occurred. You have to be ramped well down into the nether regions of the cycle to say its solar sunspot maximum has already occurred. You see, it takes almost a year or so to definitively, because of the volatility, say that, oh, we've already seen solar maximum. Now, this is an interesting feature. Sunspot 3615 has not been counted yet. Now, I don't know why that is. That just seems ridiculous because it's right in almost the exact same longitude as Sunspot 3614. You would have thought that would have gotten named already, but nope, not named. So you can expect sunspot number to go up once again tomorrow, a lot, because there are like 50 more umbra down there. So we may see sunspot number jump up over 200 before tomorrow's video. Now, I don't take the time to try to count the sunspots because that's a complex process that is kind of weird, and it's designed to be able to compare the current data to like Galileo's data and things. So I'm not going to get into all of that because it's a mess, and this is the Daily Space Weather and we're in a hurry. So press like and do it immediately because I'm not going to be reminding you again. So yeah, help the channel out, press like, etc. And let's move on to energetic particles and solar flares. So no big energetic particle events. We're seeing a ramping down here back to baseline levels. And the most significant flare of the past 24 was this an M7? An M6.5. All right, I was pretty close there. an M6.5 approximately. And let's take a look at it from the SDO. There's the 94 angstroms wavelength, and we'll play that for you here. We'll even slow it down and zoom it in, but first the full disk view, and there's some volatile activity happening up there in the northwest as well. So it's not just this area down here, it's also up there in the northwest. So, but the likelihood of activity continuing in the northwest is getting lower, and the likelihood of activity continuing in the southeast remains high. So that's what you want to see if you're hoping for space weather, which we are, since it's the main feature of the channel. So let's bring that back. Yowzers. Very nice. Very nice. And we'll play that in slow-mo for you. How about them apples? That's not half bad. The 94 angstrom slow-mo, folks. Gotta have it. So anyway, yeah, the solar flare watch continues, and it's mainly in that southeastern limb. Solar system forecast is next. That's where things will be in a week on the 25th. The 25th. It's an important day, the 25th of March. And check out the astronomy photo of the day. It's this comet, and it looks like it has a spiral around its nucleus because it has a rotating core. So it's rotating in a strange direction, and so that's the theory behind how it's creating this spiral pattern. It's the apod.nasa.gov astronomy photo of the day. And yeah, this is one that's just coming into view right now. So this one is going to be visible to the naked eye pretty soon. It's currently visible in the constellation Pisces in the early evening sky with binoculars. So if you want to check that out, that's where to look, up there in Pisces somewhere, which is in your western sky there. And then the sun's actually passing through Pisces. It's kind of near Pisces. So yeah, just after sunset, you'll be able to see that with binoculars if you know where to look. Skyandtelescope.org is not going to help you, I don't think, with that, but let's move on because I'm not too concerned about that. I'm more concerned about space and Earth weather, actual weather. So yes, comets are cool and everything, but it's little more than a novelty, really. So CMEs are next, and we do have some. Are they earthly directed? I don't think this time they're earthly directed, but let's take a look at some more imagery here. There is our LASCO C2 and C3. And there are a bunch of missing data there. So let's switch to our custom coronagraphs. How about some custom coronagraphs, folks? What do you think of that? It's, well, at the Smash News Network, it's a dictatorship, so it doesn't matter what you think of it because we're... Oh, you get the idea. So there are our synced up images. Let's actually switch back here and show stereo A. So we show this because stereo A is now orbitally ahead of the Earth, shown by that red circle. The blue circle is stereo B, and so forth. And do we have those CMEs? That data is old. Old, I tell you. All right, so let's switch back to our custom coronagraphs. All right, so we do have some interesting things going on here. Look right up in this area. You'll see some ejecta being produced up there. And the real question is that on the Earth side or the far side? And that appears to be on the far side because I'm seeing a continuous series of images from SDO. And here we've added 193 angstroms. So it looks almost like a relativistic particle event there because you're seeing some interference on the SDO, but that could be a communication issue because of local SDO side space traffic in terms of solar plasma. So that might not be, yeah, it could be transmission issues as opposed to actual strikes. I think those events are going to be minor, and they're going to miss Earth to the northwest, the upper right. So you can get your own videos at helioviewer.org, by the way, if you want to. So what we're talking about is up in this area. And you can see it's mainly just off in this direction. I don't think that is earthly directed. It may be associated with other things happening on the far side, because there are quite a few active beefy sunspots over there. We do see some plasma motions up here on the Earth side, but we don't see anything resembling a halo there. So I'm about 90% sure that's not earthly directed ejecta. I think it's a somewhat Earth-side event coinciding with some far-side events. So, but that's where we're gonna. That's my story, and I'm sticking to it. So next are filaments, Cerro Tololo, and we named this one last night, thanks to our Twitter follower that decided to name that one the Liam P filament. Yeah, it's now known as the Liam P solar filament. Of course, if you know him personally, you can use his last name, but some multiple other filaments there on the solar disk. And if I was getting one named after me, I would want it to be this one right here, because, well, this one's already named, but this one up here is right on the equator. So that's a good sign if you're hoping for Earth strikes, as we pretty much always are on the channel. So maybe that's too reckless for you, but yeah, there it is, the Liam P filament. And if you want to name filaments, join us over on x.com/smashomash. Just follow the hashtag name that filament. Before bonus features, the GOES 16 and GOES 18, or the GOES 18, just the GOES 18. There it is. And look at the prominences there up around the northern polar region, behind the northeastern limb. And look at the massive filament behind the southwestern limb. Sunspot 3599 is still casting a shadow, so to speak, on planet Earth. Look at that. That's a massive filament right there. That is, I don't know, 50 Earths in diameter or something like that. Just properly massive. Anyway, bonus features are next, so here we go. Satellite charging hazards are first. We've got some over the northern Indian Ocean. That's just some relativistic electrons there building up on the outside of spacecraft in those areas. There is our GOES electron flux, the greater than or equal to 2 mega electron volt electron fluence, as measured by radiography from the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. And here are the data for the past 1 year, the 1 year graph of the relativistic electrons. They're measured at the F layer, and there's the forecast model. And I would agree with Noah there, expecting a downtick in the electron flux. Next, the layer where it's measured, the F layer. It's at about 300 kilometers of altitude. You see? So lots of low-frequency anomalies here, and we're going to see a bunch of high-frequency anomalies, as we've had 2 CME impacts already with more to come. So you're going to see a lot lower frequencies on this as a result of solar plasma showing up and making its way down, down, down into the Earth system. So you're going to see a lot of blue replaced with a lot of red. So it's going to be a great variation here in the coming days, as some geomagnetic storms are on the way. So that's the anomaly in megahertz from a 30-day median. And we're already seeing some red popping up there at the end of that video. Next, we'll show total electron content and maximum usable frequency. Super useful for GPS and radio users. We are indeed seeing some electron content anomalies. Those free electrons affect your GPS signal transmission. We'll close out space weather with the latest awesome imagery here from SDO. So check it out. Multiple sunspots here. They're quite magnetically complex, actually. That one is beta gamma class. That one is beta gamma, maybe delta. That one there is certainly beta gamma. And then as far as these go, that one is barely beta class. And this one here is beta gamma delta. It's very sprinkled with opposite magnetic fields there. So that's what you want to see for space weather events. And we do, because we're not spooked of space weather events. Space, folks. A frontier is not spooky. So it's big. There's definitely some violent stuff going on out there, but not spooky, especially statistically speaking. All right, let's get to meteorology because meteorology. It's another bonus feature, ultimately. Forecasting Earth weather is far too easy. And pardon my keyed out forehead. I can't stand that. All right, so anyway, we're looking at the stormiest seas in the world, and right now Earth's seas are pretty calm, but the stormiest seas are in between Iceland and Ireland. I mean, Iceland and Greenland. So definitely don't go sailing on your open, Viking longboat up there, as there's a loitering low chilling here near Iceland, and it's pulling air through this thin waterway, which is accelerating the winds and creating 30-foot waves, 32-foot waves. So, yeah. By the way, I like boating on stormy seas, in case you're wondering. I find it to be amusing, assuming that, I'm not going to drown. Anyway, here come the basic meteorology segments here. Surface winds and jet streams are what we're showing. There are the surface winds, jet streams, and so on. Once again, jet streams, surface winds, and back to the jet streams. Satellites next, as we zoom in closer and closer to the lower 48. That ain't half bad. That's pretty good. That's pretty good imagery. Of course, everybody knows Earth is croissant-shaped and that NASA is projecting this fake spherical model of a croissant-shaped object onto this fake spherical model because NASA totally has incentive. NASA totally has opportunity, motive, and means to take the croissant-shaped Earth and project it onto a fake spherical template, right? What are you, an idiot? You don't know about Operation Paperclip? Anyway, spring is coming, and that ultraviolet content area is going to cross the equator. That's just the UV index. So, if you want to get a sunburn, the equatorial Pacific at noontime is always a good call for that. You want to get a sunburn. Next, our weather.gov map. And we got a bunch of freeze watches around the Gulf states. There's the key. If your location is lit, head to weather.gov and click your location. Here comes some forecast. Pressure and precipitation is the first we're showing from the Smash Weather Station. So that's a 72-hour GFS pressure and precipitation model. Here is the GFS temperature anomaly forecast for the same period of time, 72 hours. We show 3-day forecast because they're accurate. Now, of course, if I wanted to forecast your weather in a very tiny area, I could do it with a shocking degree of precision. But we only zoom in a little bit to the lower 48, and then we move on because we don't want these videos to be too long. Of course, the average human being has an attention span of 8 seconds. 8 seconds. They read a headline, and then they don't read anything in the story at all, if they even click on it. Next is our jet stream map. And there you go, 72-hour GFS jet stream, 250 millibar winds. Next, we'll show lightning, briefly, very briefly. There's a real-time lightning map, and we do have some terrestrial strikes here in New Mexico, it looks like to me. Indeed, the Petrified Forest National Park, rather, has got some thunder rolling in. Dang! Dag, oh my God, get in a bunker. Get in a bunker, folks. Oh no, space is scary. Look at the lines, they're vertical. Oh my God, it's bunker time. Or it's the equinox. Either way. You be the judge. I'm not going to tell you what to do. If you want to go hide in a bunker, hide in a bunker. I'm sure it's a very nice bunker, and I'm sure your MREs are very tasty. So there's U.S. Doppler radar. Here is satellite for the lower 48. There is water vapor, and here's your recap. U.S. Doppler radar from radar.weather.gov, if you were wondering. Here is satellite-based, basically like taking a photograph from the satellite. And here is the water vapor map, showing 6.61 micrometer infrared radiation, which will show you the dry air, the moist air, and everything in between, and it'll clear up your Doppler when it is unclear. So we hopefully we've cleared up the weather in space, all the way down to the weather on Earth, and hopefully you are not spooked of things that are completely unspooky. Anyway, see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back while I go back to the bunker again. Whoa.